Greek, but English. All right, so suppose the demand function for a firm's product is given by, this is our demand function, okay? They've told us PZ is the commodity price. So this demand, QDZ, this is the demand for good Z, okay? And PZ is the price for good Z. PW is the price of a related good. M is per capita income, income for each person. And A is advertising expenditure. Okay, so in this demand function, quantity demanded for good Z is dependent on the price of good Z, the price of a related commodity, the income of people, and the expenditure. All right. Yes. So we've been given a question. So they've told us now, let PZ equal 40 kwacha, PW equals 60 kwacha, M equals 30,000, and A equals 100. Determine the on price elasticity of demand and state whether demand is elastic, inelastic, or unitary elastic. So remember, demand is elastic. It means, let me just get talk time. My bundle's about to be done. Okay, sorry about that. The bundle's finished. Let's resume where we left off. Yes. So we've been told the price of good Z is 40 kwacha. The price of the related commodity is 60 kwacha. The income per capita is 30,000 and A is 100 kwacha. So that's determine the on price elasticity of demand and state whether demand is elastic, inelastic, or unitary elastic. So as I said earlier, when demand is elastic, it means when price changes by a small amount, quantity demanded is going to change by a bigger amount. When demand is inelastic, if price changes by a big amount, quantity demanded is just going to change by a small amount. Unitary elastic means if price increases by 2%, quantity demanded will drop by 2%. The price and quantity demanded, they're increasing at the same rate. Okay? Increasing or decreasing at the same rate. So we come to our function here. Okay. First thing that we need to do, let me just write this is the formula here. The partial derivative of our demand function with respect to QDZ, we're deriving with respect to the price of good Z. We're deriving this function with respect to the price of good Z, meaning it's the variable that we'll be focusing on, multiplied by the price of good Z over the quantity demanded of good Z. Okay, this is the formula for on price elasticity of demand. So the first thing you need to do, step one, is you need to get this Q. Okay, you get this quantity here. PZ, we already have it, is 40 kwacha. Okay, so we just need to get Q and we need to derive here. Okay, so in order to get Q, we've been told, that's why we've been given these numbers here. PZ 40 kwacha, PW 60. These values, we're going to substitute them into our demand function. Let me see if I can zoom it. We're going to substitute them into our demand function. So let me write our demand function here. Q equals 5 minus, let me just type it out. Why am I even using this? Q equals, don't worry, I'll zoom in. Just let me just write down the whole function so that we do the substitutions and then. Okay, so we have our demand function here. We need to substitute those values into our demand function so that we can find Q. Okay, so they've told us PZ equals 40, so it's a 5 minus 0.25. PZ is 40 plus 1.5. PW is 60. Oh, let's get our calculators. 0 plus 0.00003 multiplied by 30,000 plus 3A, a 100 here. Okay, so 0.25 times 40, what do we get? If I'm not mistaken, it should be 10. Plus 1.5 times 60. We get 90. Plus 0.0003 times 30,000. You get 9. Plus 300. Okay. So we're going to say 5 minus 10 plus 90 plus 9 plus 300. You get 394. 394. Any questions? That's the first thing we need to do for our formula here. Let me even type out the formula here. Then once you have done that, then the next thing is you need now to derive the demand function. You have to partially derive it with respect to x. Or with respect to pz, sorry. Okay. Let me just put this properly here. Symbol, partial derivative symbol, where is that? Oh yeah, here it is. With respect to PZ. So when we say partial differentiation, it just means we're going to only focus on one variable in the demand function, which is PZ, okay? We're deriving our demand function with respect to PZ. So it means as we derive, the only variable we are focusing on is PZ. If a number doesn't have a PZ attached to it, it means it disappears, okay? The number doesn't have a PZ. So like in this case here, this 5 doesn't have a PZ, it disappears. 1.5 doesn't have a PZ, it disappears. 0.003m doesn't have a PZ, it goes. 3a doesn't have a PZ, so it goes. Okay? So we're only deriving this negative 0.25 PZ. Okay? So if you remember with differentiation, this PZ is like it's to the power 1. Okay, so whenever you are deriving, always multiply the exponent 1 times the coefficient negative 0.25. 1 times negative 0.25, that is negative 0.25. All right, then after you multiply the exponent with the number in front of the letter, which is the coefficient, you subtract a 1 from the exponent. 1 minus 1, that is 0. So we have negative 0.25 pz to the power 0. Then anything to the power 0 is 1. So we don't need to show this. So our answer is negative 0.25. Any questions? Okay. When we say we're deriving, because of this in here, we're deriving our demand function with respect to PZ, okay? So it means any numbers that don't have a PZ, you have to ignore them, okay? You remove, okay? You remove, that's all, okay? Was that your question, madam? Why we were removing the other ones? Yes. Okay, now when we're deriving, remember, when deriving, this PZ, it's like to the power 1, okay? It's to the power 1. All these, even this PW, when we come to it, it's to the power 1. This M is to the power 1. This A is to the power 1. Okay? So when so when you're deriving, you multiply the exponent, the power, with the number in front of the letter, the coefficient. Then after you multiply the exponent with the number in front of the letter, subtract a 1 from the exponent. Yes. So now we can calculate the price elasticity. As I said, it's just a two-step process, okay, colleagues? Find Q. Once you find Q, derive. Okay. Yes. So here, this we are going to replace it with negative 0.25 multiplied by PZ is 40 over 3, and Q quantity demanded is 349 units. 40 divided by 394. Yes, the price given to us. So you do 40 divided by 394. 0.1. Yes. Then negative 0.101. Then negative 0, not 0.101 times negative 2.5. 0.25. We get negative 0.025. Okay. Then we get the absolute value so that we can interpret, is this positive or negative? I mean, is it less than 1 or greater than 1? So since this value is less than 1, tells us demand for this good is inelastic. Okay. Because this value we've calculated, 0.025, is less than 1. So we know demand for the good is inelastic.